Welcome to Nated Engineering. This is the third lesson on stress, strain, and Young's modulus, Engineering Science and 4. In this lesson, we are doing an exercise based on tensile force. The exercise that we are doing, it's an exercise taken from a question paper that was written on 1 August 2019. And it reads as follows. During a tensile test on a round bar with an original diameter of 30 millimeters and an original length of 100 millimeters, the gauge length was 111.31 millimeters and the neck diameter was 21.22 millimeters at fracture. Young's modulus of elasticity of the material of the bar is 210 gigapascal. Determine each of the following, and those are the questions. 1. The percentage extension of gauge length. Number B. The percentage reduction in area of gauge length. This is the information that we are given. We are given the diameter of the bar, the length of the bar, and we are given the final conditions of the bar. Remember, this bar is subjected to tensile force. And we know that when we keep on increasing the force that is being applied to the bar, we will end up with something like this. This will be before the bar breaks. This is the length that they gave us. They gave us the length and then they gave us the diameter. They said it's the diameter of the neck. These conditions are for the bar just before the breaking point. So it's the diameter of the length, which is D final, and it's L final, which is the length of the bar just before it breaks. And then they've asked from us to calculate the percentage extension of gauge length. Start with 7.1.1. That's equals to the percentage extension. It's equals to the change in length. Most of the time they will write change in x, but know that that is the change in length divided by the original length times 100. And then the change in length, we know that the change in length will be the original length, the final length minus the original length. And then we know the final length, this is the final length, 111.31 negative 100, which is the initial length. And then the original length is 100 times 100. And then our percentage elongation here will be 1.31%. And then that's how you go about calculating for the percentage extension. And then we go to question number 2, to the second part of the question. They say calculate the percentage reduction in area of gauge length, which is 7.1.2. We also know that the percentage reduction, it's equals to the change in area divided by the original area times 100. We know change in area, it's supposed to be the area final negative the initial area, which is the original area. But take note, in the question they have already said that the percentage reduction in the area of the gauge length. So if we put the final, notice that the final area, which is this, will be less than the original area. So here we will get a negative sign. But just because we have already been told that it's a percentage reduction, we already know that the diameter of this object reduced. So we will ignore this negative sign, and then we will do them like this: the original area minus the final area. And then that's what we are going to do here. We know that area is equals to pi divided by 4 times d squared. Then we will say pi divided by 4. Erase this. We'll say pi divided by 4. We take the common factor, and then it will be the original area, the original diameter, negative the final diameter, divided by the original area, which is pi 4, and then it's original, times 100. We can cancel these two. We know that these two are the same. We know it's squared here. These two are the same. We can cancel them out. So we can simply write them here, just like this, just to save space. Divided by original d squared. And then what is our original d? It's 30. You can even convert them to meters, but there is no use in this case. The final d is 21.22 squared, and then divided by the original, which is 30 squared, times 100. Our answer, I'll write it here. I got that my answer is 48.968%. And then we are done with the first part of our question. They've asked us to calculate the percentage elongation and the percentage reduction in the area, elongation in a length. And then we go to the second part of the question. They say when a tensile test of 90 kilonewton was done on a round bar with a diameter of 80 millimeters and a length of 0.981 meters. The extension length was 0.1181 millimeters. And then the questions. They say, number 1, determine the stress caused. Number 2, determine the strain. Number 3, determine the Young's modulus of elasticity of the material of the bar. And this is the information that they gave us. First question, they said we must calculate the stress. We know it's 7.2.1. We know that stress is equals to, this is tensile stress, therefore it will be this sign and it's force times area. What's the force that is being applied here? It's 90 times. You must convert this kilo. You must include this kilo when you are calculating. Your SI unit should be newtons. Therefore, you must put this kilo into action. And then what's the area? We know the diameter, therefore we can get the area. Convert this into meters. It will be 0.08 squared, which will give us an answer of 7.95 megapascal. You must simplify your answer. You got that long answer, bring it to megapascal. Always, when you are dealing with stress, you must try to convert this answer into megapascal, because usually your answer will be too long, so you cannot write all those numbers here. Just convert them into megapascal. And then we go to number 2. They say calculate the strain. 7.2.2. strain is equals to the change in length divided by the original length. We know the change in length they gave us is 0.181 divided by, what's the original length? The original length is equals to is 987, which will give us a strain of 1.204 times 10 to the power negative 4. This is number 2, which is the strain. And then we go to number 3. They say calculate the Young modulus of elasticity. And then we know that it is the ratio of the strain by it is the ratio of the stress by the strain. We have already calculated the stress. It's 17.905 times 10 to the power 6. We know a mega is times 10 to the power 6. And then the strain is 1.204 times 10 to the power negative 4. And then this will give us a strain of 148.713 gigapascal. Just like the answer of the stress, the answer of the Young's modulus will be that very long answer. So you must bring it to this its shortest form, and then we will use gigapascal most of the time. We know that giga is times 10 to the power 9, and then the mega is times 10 to the power 6. So always bring your stress here and bring your Young's modulus here. That's basically the end of our lesson today. Hope this lesson will be of help to you. So you have seen me drawing the sketches according to what the question was said. I'm not bored. You must always do this. It's very important. Always draw your sketches so that you know exactly what you are dealing with. You know what you're talking about. This is very helpful. Always draw. From me to you, I'll see you on the next lesson.